Yeah, in this particular session, we will see the workout of, we will take a what we call system as, we have something, let me take the annotation, and yes, now I say acetone and ethanol. This is a system we have. This is a system. And what we want here is so to carry out flash of the system. But for that, we need to specify temperature and pressure. If I specify pressure as 1 bar, which is nothing but 101.325 kilopascal, and if I assume the given what do you call composition to be as given feed composition to be as X. Okay, that means liquid phase compositions. The temperature which I find will be nothing but bubble point temperature. Similarly, others. If I specify pressure and if I assume that the given feed composition, the given mixture composition is Y instead of X, that means I will be finding, or what I will be getting then is due T. Let me actually erase this arrow. Yeah, let me write it again. So this is if I take Y and if I take P and Y, then I will be getting it as, I am fixing pressure. I'm fixing pressure and I'm assuming mixture to be as liquid. Then whatever temperature and the vapor phase composition I am finding is nothing but bubble point calculation. If I'm fixing pressure and I'm assuming feed mixture to be as Y, that means vapor, and what is the temperature I am finding is dew point temperature, or it is called as dew point calculations. So, okay. So let me erase all these things. Yeah, and now once we find, suppose say we know the bubble point, or let me write in a different fashion. Now we know T bubble, okay, temperature, and T dew temperature. You can imagine, or you can visualize which one will be less. Definitely, bubble point temperature is less than dew point temperature. Between these two temperatures only, that means the highest temperature is T dew and the lowest temperature is T bubble. Between these two temperatures only, we can say that flash takes place. Okay. Now again, let me close all these things. Yeah, let me rub all these things here. And now let me come back to our simulation. So you can see this here. I have already taken some input. So this is the input. Yeah. So this is a flash or rather, I go to separator. You can see here gas liquid separator. This is what I have picked up. And this is the input. Let me rename this as simple feed. Okay. Feed that which is required to be flashed. So the first question what I want is that yes. So I have to press enter. The first point is to estimate bubble point temperature and dew point temperature. Once you come down here, you find here the what do you call here you find the spec, you know. This is the spec you see, spec. Then you have temperature, pressure, by default it is there. Right. see, by default it is temperature, pressure is there. So I select this as pressure and vapor fraction. Here I am giving this atmosphere, or let me change this as 101.325 kilopascals. The definitely the what you call the bubble point temperature and dew point temperature depends upon the composition. Now initially I say vapor phase mole fraction to be 0. That means everything is liquid. Now go to the compound amounts. It is equimolar 0.5 and 0.5. You can see how it is being specified here, but total should be 1. I think you are getting the point. Now if I run this program, that means go to app and then solve, accept here, and then everything is done, and then solve. Okay. But I am unable to see the results here in this window. That means I have to click this and then see. But okay, now if I go to the results as vapor, see the molar flow, which is 0. Nothing is being visible. Okay. And now the bottom one, I'll scroll down. And then if you see the bottom, that means liquid output, all the molar flow is 1 kilomole. That means all the input which I have given is coming down. And the feed input temperature is how much? It is actually taking as 62 only. That means it is saying that it's bubble point. So entire operation is going at bubble point. So you know the bubble point temperature now. So what is the bubble point temperature? Let us note down. So bubble point temperature is how much? Let me actually see it here also. I can see, come here and then click here, 62.1377. See, if something I have given absurd input, you can actually correct also. So this is 62.137 degrees centigrade. Now we want d dew. So how much is the d dew? So how do I know what is the d dew? So if I come down, I change now vapor fraction to 1. That means entire operation. Now the liquid or the feed mixture I am assuming to be as what you call vapor. So that means whatever temperature I am finding now is d dew. See the temperature now, 67.4328. So let me take now write down here 60. Oh, 10. Yeah, 67.4328. Okay. That means now the flash will take place in between these two. That is what we need to understand. The flash calculation now will carry out between these two temperatures. Okay. So for a calculation purpose, let us take as T flash as 1/2 times these two temperatures. Okay. So bubble plus dew.